what we're going to do is see how to use phyphox to do some recordings of free fall to find the acceleration. You open phyphox and you decide to do an experiment. I'm going to drop my phone, so I'm going to call it drop phone. I don't want thousands and thousands of points, so let's say I do 10 per second, 10 Hertz. To make it simple without gravity, I want it linear acceleration. OK. Then I basically have to decide I want to only record for a certain period of time. We'll do a timed run. We'll start after 3 seconds and we will last for 3 seconds. 3, 2, 1. Now drop my phone. There. So this is the data that I'm going to use. Now, since the phone was on its back, this is the Z direction. So if we look carefully at the Z axis acceleration, you notice that after about 2/3 of a second, that's the point when I drop it, there will be an acceleration of approximately 10 meters per second squared downwards, and then suddenly there's an acceleration of around 70 or 80 meters per second squared upwards. When I drop it, that's when it accelerates down at 10 meters per second squared. When it hits the cushion, that's when there will be an acceleration in the opposite direction, which is much greater. So these are the points that we need to be able to highlight and discuss. Now what I want to do is to save this data and send it to myself as an Excel sheet. So export data, Excel, we'll share via Gmail. I'll send it to myself. And now I should get a copy of the data in my inbox. Now I've just opened the data here, and since we're focusing mostly on the Z axis, which is the 4th column, I'm interested in the time and in the linear acceleration in the Z direction. So we'll select all this, Control, and linear acceleration in the Z direction. Now I will sketch the graph. Insert, scatter graph. Now if I enlarge this, we can see much clearer what's going on here. So this is after 1, 2, 3, 4, 0.5 seconds, 0.6, at that point I drop the phone. It is accelerating downwards with an acceleration of roughly minus 10 meters per second squared. Then suddenly we have an acceleration in the other direction as it hits the cushion, which is upwards of 70 meters per second squared. Then it bounces off the cushion and is falling downwards again with that same acceleration. Then afterwards the acceleration is 0. That means it has come to rest, or the velocity is not changing. And that's how I want you to do this. Now if I were to do this again, I can see at the point where it's bouncing on the cushion, there's only one point, so I would have probably have taken 30 Hertz instead of 10 Hertz, or maybe 40 Hertz or 50 Hertz, just to get a high frequency there. So this is what you need to be able to do. You need to be able to illustrate this kind of data on the graph and explain what is happening at different parts of the fall using the graph.